Hey everybody, it's Alex with Engineering Applied. In this video, I'll be giving you an overview of the pattern command found within an Autodesk Inventor assembly file. If you want more easy to understand and practical content like this, made by an experienced engineer like myself, make sure you like this video, subscribe to the channel, and turn on notifications so you don't miss out on any helpful content like this in the future. If you're looking for a specific function, check the description for timestamps, and if you don't find what you're looking for in this video, make sure you check out the other videos in my Autodesk Inventor series playlist because I know you'll find exactly what you need there. Let's get started. Okay, everybody, so here we are in our assembly file, and what we're taking a look at in this lesson is how to use the pattern tool to make our design more efficient. So in this case, we're looking at a DC motor and mounting that motor to an adapter plate. So you can see I already have a fastener here going through the front side, and it rests on this little step in this counterbore hole. And then on the back side, we have a split lock washer and a nut retaining everything together. And of course, we can use some Loctite or whatever is necessary per our specifications. And so what we're doing here is we're going to use the pattern tool to essentially replicate the fastener, the washer, and the nut all in one step, and retain all of the relationships to the mounting plate that the first set of fasteners, nuts, and so on and so forth have with the mounting plate. So what I'll go ahead and do first before we jump into actually using the pattern tool is I'm going to delete these elements out and then replace them into my assembly and constrain them so you can see exactly how I have them constrained before we pattern these components within the design. So what we'll do first is we'll just go up here and I'm just going to delete these components. Okay, you can see now we don't have those the fastener, the nut, and the washer. So now we can go up to place. Let's go to, we'll bring in the fastener, the hex nut, and the split lock washer all in one go. We'll hit open and just drop them anywhere, it doesn't matter. Okay, so let's go ahead and put the fastener in place first. We'll go ahead and go up to constrain. Now, if you're unfamiliar with how to create constraints within an assembly, I encourage you to go watch my video on that because I give a comprehensive overview of all of the subcommands contained within this window. Okay, so we'll go ahead and use the insert constraint, and let's start with the fastener here. So we'll pick up this bottom edge, and what this is doing is it's going to align the central axis of this with the central axis of this hole, and it's going to set this edge here flush with this edge here. So we'll just click on that and you'll see it snaps it into place. And let's lock the rotation because when this is all tightened down in reality, we're not going to see any rotation out of the screw or any of these other components. In an ideal scenario, of course, you don't want these components to be able to spin while this motor is operating. Okay, so we'll hit apply on that and we'll repeat those steps with these other two components here. So we'll just grab that edge, drop it right here. We'll make sure that the rotation is locked and we have that box checked. So we'll hit apply and we'll do the same thing with this nut. Okay, and we'll drop it right here. Okay, now that we have everything completed for those set of constraints, now we can look at the pattern tool and see how we can pattern this set of components all the way around in one step rather than having to do all of that individually for all four holes. Now let's go ahead and move up to our pattern section within the ribbon here, and we're going to click on pattern. And now we get our pattern component command window that pops up. So let's start in the top left-hand corner and work our way down. So this is our component selection filter. So when it's active, and I know it's active currently because there's a blue fill inside of the box. Okay, so when this is active, we use this to pick up the components of interest that we actually want to replicate. Now moving down, we have three main sections. Our first section or tab is the Associative tab. So simply put, what this allows us to do is it allows us to call on another feature pattern. So for example, in this mounting plate part file, I created a rectangular pattern for these holes, okay? So we can call on that rectangular pattern in the assembly level to replicate these components. This next tab is the rectangular pattern tab, and this allows us to create a rectangular pattern with our components. So we can designate two different directions. So we could specify this edge so that it patterns in this direction, and we can set a quantity for our pattern components and a spacing value, and we can do the same in this bottom direction. Okay, and then this final tab here is our circular pattern tab, and that just creates a circular pattern. So we'll step through each one of these tabs, and I'll show you how we can accomplish the same end result using these various features. Now let's go ahead and create an associative pattern. So the first thing we want to do is we want to select our components of interest. So we're going to select this fastener this washer, and this nut. Now, if you accidentally selected something, what you can do is you can hold the Shift key and you'll see it highlights that component in green. And then while holding Shift, you can left click and it'll deselect that. You can also select entities from your model browser. So we'll hover over Hex Nut and just left click and you'll see it picks that up for us. Now let's go ahead and take a look at our feature pattern select button here. Again, this allows us to pick up a feature pattern of interest. So in this particular case, when I designed this mounting plate, I included a rectangular pattern feature here to create this whole pattern. And I did that on purpose, not just because it's more efficient in your basic design phase, but you can recall this particular pattern feature in the assembly level and use that to pattern your components. In this case, it'll be the fastener, nut, and washer. Okay, so let's go ahead and take a look at that. I'm going to cancel out of this command window real quick so I can show you that feature pattern that I created in the part level. I'll right click on this mounting plate and go to open so we can open it by itself. Okay, so go over to the model browser here and we'll take a look at the rectangular pattern. So I'll just left click on that and you'll see that is the pattern that I created these holes off of. And so initially what I did was I created a sketch on this plane and I'll show you that. So it was just a reference sketch. So I created the whole pattern and just turned this all into construction geometry. And then I placed the actual hole feature on this corner here, only one corner. Okay. And I did that on purpose so that we can use the rectangular pattern in the assembly later on. So we'll just click finish sketch. Okay. And then I placed this counterboard hole on this one corner to the specifications that I needed. And then I created this rectangular pattern. Okay, so now that that was done, we can go back into the assembly and, like I said before, recall that feature pattern for our component replication. So let's do that. We'll go just exit out of this. Okay, now let's go back to pattern. We'll reselect our components that we want. So I'm going to pick up the fastener, hex nut, and split lock washer. Okay, and so now that we have those selected, we'll activate this selection filter. And let's go ahead and hover over our hole pattern. You'll see it automatically highlights in green because the software recognizes that there is a feature pattern there. So we'll go ahead and left click on that. And you'll see it populates all of those locations with this set of components. And once we've done that, we can click OK. And let's rotate this around and I want to show you something. So if I hover over any of these, they're all highlighted together, okay, because they're also associated with one another. And you'll see when I left click and drag on these, they don't move anywhere. And that is why this particular function is so nice, because not only does it replicate the components, it replicates their relationship to the part itself. So these fasteners aren't going to move in space. They're already pre-constrained because they're based off of the designations that this first fastener has. Now, before we move on, I want to show you something else. So let's go up to the relationships folder and we're going to right click on insert 3 and go to edit. This is the constraint between the fastener and the mounting plate. And what I'm going to do is I'm going to unlock the rotation and click OK. And now when I click and drag on this component, let me zoom out a little bit. You'll see that all of the other fasteners rotate with it, okay? So I just wanted to show you this to prove that these other components are tied in with the first one and its set of constraints. Okay, now let's take a look at our rectangular pattern tab. So we'll just left click on that. And of course, at the top left, we have our component selection filter like the Associative tab. Okay, so this is where we select our components of interest that we want to create a pattern with. And then moving down, we have our column and our row section. So we can replicate components in two directions using this tool in one step. So we can, for example, pattern in this direction and then pattern in this vertical direction all in one shot. So let's go ahead and do that now. Let's go ahead and select the components that we want to pattern. So I'm going to pick up this fastener here, this washer here, and this nut. Okay, now let's move down to our column section. So we'll click on the column direction selection filter. So this allows us to pick up a reference. So we can pick up an edge or an axis. So if you go under the origin folder in your assembly section of your model browser, you can pick up one of these 3 axis elements and so on and so forth, whatever it is that you need to create the proper pattern direction. So in this case, I know that this edge is parallel with the line that connects these 2 holes. So we'll go ahead and pick that up. So once we click on that, you'll see that the head of the arrow is facing left and it's patterned the fastener in the wrong direction. So what we can do is move over to this button, which says flip direction. When we do that, it flips the direction. So now our pattern component is on the proper side. Moving over to the right, we have our midplane option. So if we were to click on that and enter an odd number in this box, so we'll just enter a 3, which, by the way, your column count includes the original component that is being patterned. So we have 3 total components, not 3 in addition to the original. So just remember that. Okay, so when you have an odd number of components and you use the midplane option, what will happen is it'll evenly distribute the new components about the original. So you'll see our original is acting as the midplane there, and we have our 2 new components. Okay, you don't have to use an odd number. You know, if you use an even number in there, it'll just be an uneven distribution about the midplane. Okay, and if we go to 5, it'll add 2 on either side of the original. Now let's go ahead and deactivate this midplane option, and we'll enter a value of 2 because we want 2 total components, one acting as our original and the second one acting as our pattern component. And so now we want to move down and take a look at the column spacing box. So this is where we enter the spacing between these 2 components. And as you can see, we're obviously not at the correct spacing here. So we need to go ahead and correct that. We can do that a couple of ways. The first way you can do this is you can go ahead and cancel out of your pattern component option, and you can right click to go into your marking menu and click measure. Okay, and you could just simply measure between these 2 elements here, and it tells us our spacing. So 1.860 inches. We can go ahead and copy that, exit out of that, go back into pattern. Okay, go to rectangular. We have to select our components again because we cancel it out of the command. And once we've selected our components, we can go down to column once again. So unfortunately, this way you have to sort of do everything all over again. Flip that. Okay, now we can finally get down to our spacing value here, and we can just paste in that value that we found. Okay, so you'll see now we have the correct spacing. There's an alternate way to do this. So prior to using the pattern, you can use a little bit of foresight to plan out your next steps. So what we can do instead is we can go to the model browser, click on modeling. Okay, and this allows us to see the specific model elements within our various components. So I can go into my mounting plate, go into the hole that I created, the initial hole, and let's toggle the visibility of that sketch. So I can right click on sketch, go to visibility, and now I can see this at the assembly level. So when we go back to our assembly tab and then repeat those set of steps with our rectangular pattern, let's go ahead and select our components again. Okay, so you can see that this sketch is still visible. Now this is helpful for when we want to pick the direction. So we can actually pick up the edge first, flip that direction. Okay, now you'll see our count is correct, and now our spacing is still incorrect. So what we can do is we can just delete that value from the box and go to this little arrow on the side. We can go to measure, and now we can pick up this line element. So we can actually measure the center to center distance based on that sketch that initially set the pattern distance anyway. So we can go ahead and left click on that, and you'll see that it picks up that distance for us and the part snaps into place. So now we can go ahead and either click OK, or we can go ahead and pattern in the second direction before moving on, which is the path I recommend because it includes everything in a single step rather than splitting it up into separate pattern features. So let's go ahead and make sure that our row direction selection filter is active, and it is because there's a blue fill in the box. And I'll go ahead and just select this edge here for our pattern direction. You'll see the head of the arrow is facing down, which is the correct direction this time, but our spacing is off. Okay, so after verifying that our row count is correct, we can move down and go ahead and measure this line, and it'll get our correct spacing. And we should have everything good to go from here. We can go ahead and click OK. And now you can see everything is locked into place as intended. And I went ahead and went back and locked the rotation of this initial fastener again. Okay, so let's go ahead and move on to our circular pattern tool and see what we can do with that. I'm now back in the pattern component command window, and I'm going to click on the circular pattern tab. Okay, of course, at the top left-hand corner, we have our component selection filter. So let's go ahead and select our components of interest. All right. Now, moving down to the left side here, we have our axis direction selection filter. I'll go ahead and click on that. And now we can designate our axis direction. So I can either hover over a circular face and it'll pick up the central axis to that face, or I can pick up a reference axis or something like that that I may or may not have in my model. So in this particular case, I don't want to include a reference axis because that's unnecessary. I know that this whole pattern is central to this cutout in the mounting plate, so that's sufficient enough for this example. So we'll go ahead and left click on this face, and you'll see we get a dashed blue line that acts as that central axis that these components are going to be revolved around. Okay, moving over to the right, we can flip the direction of our pattern components. And then, of course, moving even further to the right, we have our midplane option. Okay, so this works the same way as it does in the rectangular pattern. So it essentially uses this original component as the midplane component. So let's actually put an odd number here. And you'll see that it evenly distributes the new patterned components about the original central one. Okay, so let's uncheck that and set this pattern count back to 4. So again, this is the circular pattern count. So we have 4 total units. And then of course, moving down, we have our circular angle between the pattern components. And these are all at 90 degrees with respect to one another. So by default, we have all of the correct settings here. So I'll go ahead and click OK to finish the command. And as you can see, all of our pattern components are all in the correct location, and they all share the same set of constraints that the initial set of components have. So when I click and drag on this, nothing is rotating, nothing is moving. Okay, everything is frozen in space as intended. Now, before I go ahead and finish up this video, I want to discuss these last options here on the right side for the circular pattern option. And this allows us to control the rotational characteristics of our replicated components. To demonstrate this, I went ahead and modeled up a basic profile for a circular printed circuit board. So let's say, for example, we're designing a ring light and we need to get a basic profile drawn up so we can place our LEDs properly before we send this off for our electrical design team to place our drivers, resistors, and so on and so forth. Okay, so this consists of our printed circuit board profile and our LED. Okay, so this is a surface mount LED that's soldered on to the surface of this particular PCB. And this can be done either via pick and place, or it can be done with a solder stencil. So anyhow, what we want to do first is we want to select our components of interest that we want to pattern. So in this case, it's just the LED. So we'll select that. Okay. And then let's go ahead and select our circular axis direction. So we'll just hover over this face here and pick up that central axis. Okay, we'll go ahead and set our parameters. So let's say, for example, based on our power requirements, our heat dissipation requirements, and so on and so forth, we want to use a total of 40 units. Okay, but we need to change our angle between those accordingly. So what you can do is you could do 360 degrees divided by your quantity, which is 40 in this case, and that'll evenly distribute them along the PCB. Okay, so let's go ahead and rotate this around just a little bit. And so our spacing looks good. We're meeting our design requirements. So let's move over to this section. Now, by default, our first option, which is our rotational option, is pre-selected. So essentially all that means is it retains the basic orientation with reference to the axis. So if you were to draw a line, let me take a top view here. Okay, if we were to draw a line from this center point all the way out to this flat face on the bottom of this LED, it would always retain a 90-degree angle between this face and this line. Okay, so as these parts rotate about this axis, it's always retaining that 90-degree relationship between that reference line we would draw out there and the face, okay? On the other hand, this option retains a fixed orientation all the way around based on our original component that we're creating a pattern off of, okay? So you see they're all facing in the same direction as they're rotated around that central axis. So let me just jump back and forth between the two options so you can see the difference, okay? So in the case of a ring light, you'd actually want it to be in a rotational orientation so that you get an even lighting characteristic as it goes all the way around. You don't want any hot spots or anything like that to show through the lens or diffuser that you're using, okay? The whole idea is to evenly distribute the light so you get nice coverage, okay? So anyhow, let's go back to fixed, and then let's take a look at this base point selection filter here. So when we click on that, we can pick a new base point. So you can see currently we have the center point of this particular LED selected, and that's what it's basing this radius off of, okay? So it's basing it off of the center of this. But if we go to the top and select, let's say, for example, this central point just above it, it changes how the radius of this pattern is handled. So it's basing the radius off of this top point rather than the center point. And you can see it kind of skews the end result here for us. So that is what your base point selection filter does. And once you have everything set to your required specifications, you can go ahead and click OK, and that'll finish the command for you. And now you have your patterned component. That's all for this segment of the Autodesk Inventor assembly creation module, where I gave you an overview of the pattern command. I really hope that you found this tutorial to be helpful and that you put what you've learned into practice so you can continue developing your skills as you work your way through these lessons. Also, before you watch the next video in the series, make sure you subscribe to my channel and turn on notifications to stay up to date on future content that will help you create the future you want for yourself. And of course, don't hesitate to leave a comment or reach out via my website contact page and let me know if there's anything else you'd like to learn about or see on this channel. I really appreciate you choosing to stop by and learn with me, and I'll see you again soon.